Okay, the second goal of the remainder and factor theorem is talking about factors of a polynomial. Okay, so we know that if we divide something by something else, we're going to have a remainder or not. We might have zero we could have zero as a remainder, which means there isn't a remainder. Okay, so the question I have for you to start with is, with that concept, if you take 35, okay, so just the number 35, and you divide by 5, what is the remainder? Okay, so here's the answer. We take 35 and we divide by 5. It goes in there 7 times. We get 0. So the remainder is 0. Now, the question I have for you is, would you consider 5 to be a factor of 35? Okay, so is 5 a factor of 35? And of course, the answer is yes. You would consider 5 to be a factor because the remainder, when you divide it, is 0. So yes, it is a factor. Okay, that's the concept we are using with polynomials. Okay, so let's go ahead and talk about that concept. All right, if you take a polynomial, x cubed minus 3x squared minus 4x plus 12, and you divide by x plus 2, what is the remainder? Okay, so this is where synthetic division comes in, or substitution. If I am going to divide by x plus 2 and I want to use synthetic, I put in -2 into the box, okay? And 1, -3, -4, 12. Now, to get the remainder, remember that is this number right here. Okay, so I drop the 1, multiply, add, I get -5, multiply 10, add, I get 6, multiply -12, I get 0. So the remainder is 0. Now, do you consider x plus 2 to be a factor of f of x? And the answer is yes. Okay, so as a result, x plus 2 is a factor of f of x. Okay, so that is what your result is out of that. If the remainder is 0, then what you're dividing by is considered a factor. And that is the factor theorem. Now, if the remainder is 0, so f of x divided by x minus r. Okay, so f of x is divided by x minus r, or what we could say is f of r equals 0, then x minus r is a factor of f of x. That is the factor theorem. So let me just repeat that. If you divide f of x by x minus r and the remainder is 0, or the same thing we just learned on is the remainder theorem, that if you took f of r and got 0 as your evaluated answer, then you consider x minus r is a factor of f of x. Now, I want to just quick talk about this graphically. All right. When we talk about graphing, and our graph of a polynomial crosses the x-axis, whatever that is, so let's say that's a, f of a equals 0 at that point. Why? Because the y value of that point is 0. So when you evaluate x, or in this case a, at that point, you get 0. We also figured that the 0 then is a, and the factor that houses that 0 is x minus a. So if you know that your 0 is a, you know the factor of that polynomial is x minus a, because f of a equals 0. You're going to have to think about that. We also know that if this one is b, b is a 0, and a factor would be x minus b. Okay, so anywhere there's a 0, or the evaluated answer is 0, the remainder is 0, then you consider that x minus that number as the factor. Okay, so graphically it makes sense, and that's what the factor theorem is all about. When you have a 0, you also have a factor. Okay, so let's look at this. This is out of the book. It's example 3 on the page 354. So example 3, page 354, at the bottom of the page, it says to find all factors of f of x equals x. Oh wait, no, this is not the right example. Nope, it's not the same. This is exactly what I was talking about here. I'm sorry, I'm just, I got ahead of myself a little bit. I wanted to talk about this type of an example. This is just like example 3, but it's not the example 3. Okay, to find all factors f of x. Okay, so we have the same polynomial over here and the same thing I'm dividing by. It says to find all factors of this polynomial knowing that you have one factor. Okay, so I've got a polynomial and I know I have one factor. It's like saying this. If I have 70 and I want to find, and I know that 5 is a factor. To find the rest of the factors, I divide by 5. So I take 70 divided by 5 first, and I get, let's see, it goes in there once, 14 times. So I basically know that 70 is 5 times 14. Well, then I can try to factor 14, which of course I break that down into 2 times 7. So 70 is 5 times 2 times 7. So if you know one of the factors of your number or polynomial, you can divide that out to break it back down further. So if I know that x cubed minus 3x squared minus 4x plus 12, and I know one of the factors is x plus 2, I am looking for the rest of the factors by dividing both sides by x plus 2 first. So when I do that, and I already did that over here, the second factor now, so right here, is x squared minus 5x plus 6. Okay, so at this point, I know that x cubed minus 3x squared minus 4x plus 12 is x plus 2 times x squared minus 5x plus 6. So it's just like I broke the 70 down by dividing by 5, so I know 70 is equal to 5 times 14. I know this polynomial is x plus 2 times this factor. Well, now to find the other factors, I try to break that down further. So I know x plus 2 is still there. I try to factor this out further. I end up with negative 2, x minus 2, and x minus 3. There, I have a polynomial. I knew that one of the factors was x plus 2. I divided that out, and then I broke the second factor down as far as I could. That's what we're doing in the rest of this section. Okay, so now let's jump to example 3. It says, show that x minus 2 is a factor of x cubed minus 7x squared plus 4x plus 12. So let me write that down. Okay, so it says that x minus 2, show that x minus 2 is a factor. Okay, we show it's a factor by showing the remainder is 0, according to the remainder theorem. Okay, so we show that x minus 2 is a factor of x cubed minus 7x squared plus 4x minus plus 12. Okay? So we show that x minus 2 is a factor. Okay, so we do that by using synthetic division or substitution, and we plug in 1, -7, 4, and 12. Okay? If this is a factor, our remainder should be 0 when I do this. Okay? And again, just to reiterate what I just did over there, I'm basically showing that x minus 2 divides into this however many times that polynomial is. Okay, so I'm looking for this polynomial. Now, drop the 1, multiply, -5, multiply, add, I get 6, -6, multiply, I get -12, and sure enough it adds up to 0. Then I take this and put it up into here. So that's 1x squared minus 5x minus 6, very similar to the one I did over here. Now the question says find the remaining factors. Well, the remaining factors would be whatever this factors into, which is x minus 6 plus 1. So there's my factored form. I just factored this polynomial using synthetic division and the factor theorem, and then breaking it down further as far as I can. And we're going to be using this concept for the rest of the chapter and various times in the rest of the book.